So in this lesson, we started out thinking about point estimates, which are just single values, and using a single number to estimate the population parameter. Well, so now we're in the part of the lesson where we are generating a range of numbers as our guess, and that gives us a greater chance of being right, that our range is actually going to capture the parameter that we're after. So for this particular example, we are asked to construct a confidence interval for the population proportion. So the proportion would be the parameter that we're trying to estimate. And this is, of course, because it's a parameter, it's all about the population. So how many people in the population, or what proportion of the population, have a certain characteristic? Well, the best that we can do or work from is what our sample is telling us. And they give us a little information here, and they tell us that x is 30 and n is 150. So that means that 30 out of the 150 people in the sample have the characteristic that we are interested in. If you take 30 and divide by 150, you'd get 0.2. So the proportion that if I were using a point estimate, then that's a single number, I would use what the sample tells me as my guess. So I would guess that if 20% of the sample shows me this characteristic, then 20% of the population does as well. But again, in this part, we want an interval. We want a range of numbers, and we want to be 90% sure that the interval that we're generating is actually going to capture the true value of the population parameter. So it might be 0.2, it might be a little less, it might be a little more. All right, so the screenshots that are here go with the Inspire calculator, but let's work through it on in this case, this is an 84. It should work just as the same as on an 83 plus. Okay, so I'm going to mash the stat key and then toggle to the right and then right again over to test. And we're not testing here, we're constructing intervals. And if you notice, at the very bottom of your screen, it starts giving us some interval kinds of options. And so I'm just going to toggle down until I see the one I'm hunting for. And because we're estimating a proportion and we're dealing with only one sample here, then it's a one proportion z interval that we want to construct. So we're just going to choose that. And it's going to ask me for information. And so x is 30. That's how many people in the sample have the characteristic we're interested in. N is the sample size, that's 150 here, and the confidence interval is 90%, so I'll key that in as 0.9. And then I'll go down and calculate, and here's the interval, and you'll see that it matches the values that are in those screenshots. The left-hand endpoint is the 0.14628. That's also called the lower bound of the confidence interval, and then the right-hand endpoint is the 0.25372, and that would be called the upper bound of the confidence interval. So where a point estimate would take 30 and divide by 150 and get 0.2, you'll see that the 0.2 is caught in this interval, but the interval extends it. It goes a little to the left of 0.2 and a little to the right of 0.2. So it gives us a range, a way of estimating what the population parameter might really be. Okay, in the rest of the lesson here, you're asked to do one of these on your own. And we have a confidence interval that we want to construct for the proportion. And here's the information that we have for the sample, that 400 out of 1,200 people in the sample have the characteristic that we're interested in. And now we want to be 95% confident of our results. So let's just run through those calculations again. I'm going to clear what I have. I'm going to hit the stat key and then right to test, and I'm going to go down. Choose that one proportion z interval again. That's choice A. Now x is 400 and n is 1,200. And then the confidence level is 0.95. So you're just going to go down, you're going to mash the calculate button, right, or hit enter and it'll do it for you. And then the lower bound of the interval would be the left-hand endpoint, and the upper bound of the interval would be the right-hand endpoint that you get. And then I think they're going to ask you for an interpretation. Well, for any confidence interval that you're doing, the confidence level tells you how confident you are of something happening. And so the two choices that you have here, are we confident that the proportion is between the lower and upper bounds of the interval, or Is there a 95% chance that the population proportion lies between the two bounds? But the thing to remember here is that the chance that's involved in the process isn't attached to the proportion of the population itself, right? The chance, the error, the variation is all associated with our sample. The population proportion just is what it is, and in our sampling process, we're generating an interval that we're going to use to estimate that proportion. And so there's no probability associated with that proportion for the population. It's the fact that in this particular interval, we're 95% confident that we've captured the proportion, so that the portion is really between the lower and upper bounds of that confidence interval. Okay, I hope that helps. And